I'm here with Trevor looking at this machine, and here we have an example of the core part and the electrode that's been milled on the UX450. Trevor, what can you tell me about this application?
All right, so these are the electrodes that we've come straight off the UX milling machine. We know they're bang on centre through the Eroa tooling. We know they're all the same height. So it's just a case of probing the centre of each part, touching on the top once, and then we're good to go.
And the beauty of this machine as well, which Trevor's spoken about, the Eroa tooling, that's a 0-point system, so they can be milled offline and they can be loaded into the tool changer. And every Sodick machine comes standard with a tool changer. This machine has a 32 tool changer option, doesn't it? So 32 stations on board the machine allows you to put extensive electrodes in there for multiple workpiece manufacture. So Trevor, on the control then, how are we programming this specific electrode?
All right, so we're programming Sodick's onboard system. It's just a case of choosing your electrode shape, then answering these questions, so the depth you want to go, the electrode material, surface finish. From that information, the programming system will tell you the best spark gap to put on the electrode for the optimum performance. Input the spark gap, orbiting pattern, and basically that's it. Next page, it generates the machining data, and then on the next page you tell it where your parts are on the table. So we've got 60 datums, so I could put 60 of these on and set each one individually, load up the tool changer, and it can run for days.
So that's quite unique, isn't it, Trevor?
Mm-hmm.
What we've found, and multiple loading is becoming quite common, and the larger tool changer and the larger datum set on the machine works really well for lights out running and longevity of machining. But the other thing that I wanted to touch on, and Trevor's just said, alluded to, is we've not only got technology in there for copite, we have an extensive database for graphite, don't we?
Basically anything. So carbide, aluminium, steel, titanium, tungsten, diamond, sorry.
Yeah, it was a PCD, polycrystalline diamond. So we still have a lot of, there's lots of application databases in there. But if you wanted to develop something, that's something that our apps team can also do. And we've done that a lot, haven't we, recently?
Yeah, a lot.
So the other thing I wanted to point out as well, we not only spark well in Z on the Sodick machine, because of the linear motor technology, we can spark in X, Y, Z, or a combination of all three axes for subgates and vectoring, which historically was a slower process in other axes. We can achieve the same speeds, can't we, Trevor, in X, Y, and Z?
Yeah.
Okay, so that's a summary of all the Sodick die sinking range that we have here. Thank you for that, Trevor. If anybody's got any questions or would like to get any more information on the machines, all the team are available. Come and see us and we can run you through anything to do with die sinking.